Express 2 cos 3x minus 3 sin 3x in the form r cos of bracket 3x plus alpha, close bracket, where r and alpha are constants. R is greater than 0 and alpha lies between 0 and pi over 2. Give your answers to three significant figures. F of x is equal to e to the 2x cos 3x. Show that f dash x can be written in the form here, where r and alpha are the constants found in part A. Hence or otherwise, find the smallest positive value of x for which the curve with equation y equals f of x has a turning point. So I've written it all out here. So we need to write this thing here in the form of r cos of 3x plus alpha, and let's work that out then. So 2 cos 3x minus 3 sin 3x. So part A here, 2 cosine 3x minus 3 sin 3x is equal to, and we're going to let it equal r cos 3x plus alpha. R cosine of the 3x plus alpha. Using the compound angle formula, we've got r cosine cos alpha minus sin, isn't it? R lots of sin 3x sin alpha. So straight away we can read off the correspondences in cosine and sine. So here r cos alpha must equal the 2, mustn't it? And that's the first piece of information. The minuses tally up, so we're just left with r sine alpha equals 3. And that's equation 2. So that tells us then that r is equal to, if we square both of these, we'll get r squared cos squared plus r squared sine squared, which corresponds to r squared. When we take the r squared outside the bracket, we get cos squared plus sine squared, which is 1, is 2 squared plus 3 squared. 9 plus 4 is 13, so that tells us what r is then. R is equal to, because it's a positive number, is the square root of 13. Now for the alpha, 2 divided by 1 gives, doesn't take a moment to do, this divided by that, the r's cancel to leave tan alpha, and that equals 3 over 2. Now alpha is an acute angle, so we just do shift tan alpha, don't we, of 3 over 2. So shift tan alpha of 3 over 2, we need to work in radians, wasn't it? Yeah, I think it was. We're in radians mode, so shift tan of 1.5, which is 3 over 2. And we get the radians 0.98, three significant figures, I think I remember. 0.983. We'll come back to this in a moment. Let me just go back and check the question quickly. Yeah, 0.3 significant figures. So that's fine. And that was to 3 significant figures. And r is equal to root 13 then. Square root of 13. 3.61, isn't it? Third significant figure. The 5 rounds to 0 up to 1. 3.61. So there's our answers then, that we can proceed with these values. So let's look at part B. Now, okay, so fx equals this. Show that f dashed x can be written as this here. So let's differentiate e to the 2x cos 3x. So fx is equal to e to the 2x cosine of 3x. This is part B. So f dashed x is a product. We use the product rule. Each constituent is itself a function of a function. So it's u times the v dx, which cos goes to minus sine of something, multiplied by the something differentiated, which is 3. U to v dx plus v, which is the cos 3x, times du dx. E to the something differentiates to e to the something, multiplied by the something differentiated. So we end up with then, we'll take the e to the 2x outside, a bracket, and we get 2 cos 3x minus 3 sin 3x. And that was hopefully what we had above, so that would equal then, here, r, which is 3.61, cos of 3x plus alpha. So it's equal to e to the 2x times 3.61 cosine of 3x plus alpha, which was 0.983. So there's f dashed, and let's just go back up and verify that we're okay. Yes, we've done that here. E to the 2x cos of that, where alpha and alpha are the constants in part A, hence or otherwise. Find the smallest positive value of x for which the curve with equation this has a turning point. So the smallest positive value when this equals 0. Here, f dashed of x equals 0 when, so let's have a look at this. Well, this is the form that we had. We should really have written this number in the front because it's r e to the 2x, isn't it? But that's okay. So what have we got here then? So this equals 0 when this value is 0, because this never equals 0 for any value of x, the exponential. So we get 3x plus 0.983 equals 0. Now when is the first value when that's 0? Okay, well presumably it would be at pi over 2. 3x equals, well it would be pi over 2 minus 0.983. So x is equal to a third of that. Which equals, now let me just check on the x values, see what range of x domain of x we're talking about. So we're talking about just this function here. We've got it in this. Find the smallest positive value. So the reason why I thought it was pi over 2 here, right, was simply because looking at this is 1.6. So this will be bigger than the 0.983, so it will give the first positive value. So we get this. Let's tap it in the calculator then. We get pi over 2. I'll just work out the inside bit first. Divided by 2 minus 0.983 equals that, and then divide that by 3 equals 0.196, isn't it? 0.196, and that was to 3 significant figures. And that's what the question asks for. Find the positive value, smallest positive value of x for which the curve has a turning point. So yes, this is the smallest positive value when f dashed x equals 0.